Today we are going to talk about the quantity of chemicals that are required to making the hydrogen gas, the number of balloons that can be filled with the chemicals, and the pressure generated inside the hydrogen gas cylinder. This is a crucial topic because the existing process which is applied by the balloon vendors is haphazard and many explosions of this cylinder has been occurring because of the lack of knowledge. To make hydrogen gas, we need sodium hydroxide, also known as lye or drain cleaner, and aluminium in any form, either in scraps or in powder form. The reaction occurs as sodium hydroxide reacts with aluminium metal with water to produce the hydrogen gas. This is a fast and high heat generating reaction. In this reaction, hydrogen is formed as a gas and the other unreacted and formed product remain in liquid solution in the cylinder. 80 grams of sodium hydroxide and 54 grams of aluminium produce approximately 6 grams of hydrogen gas. 6 grams of hydrogen gas is equal to 66.66 liters of gas at standard temperature and pressure. The ratio of sodium hydroxide to aluminium to water becomes 100 gram is to 67.5 gram is to 135 grams for complete reaction to occur. The water can be added in excess quantity, and aluminium can also be added more as it is cheap. This ensures complete reaction of sodium hydroxide, which is costly and is expensive and should not remain in the solution as it is corrosive chemical. The excess aluminium and water ensure that the entire sodium hydroxide is finished in the cylinder. Now, to understand the balloon filling, we first need to understand what pressure is generated inside the cylinder. Take example of filling 100 balloons of 10-inch diameter at one time in a cylinder with a volume of 15 liters. Volume of 10-inch diameter is 8.6 liters. The pressure in the cylinder must be controlled and checked with pressure gauge. And for safety reasons, the maximum pressure in the cylinder should not exceed half of the bursting capacity of the cylinder. For a 200 atmospheric pressure capacity cylinder, it should only be filled with hydrogen below a maximum of 100 atmospheres of pressures, which must be controlled with the pressure gauge. Then the pressure generated in the cylinder will be P1V1 is equals to P2V2. 1 atmosphere into 100 balloons into 1 balloon 8.6 liters equals to P2 into 14 liters capacity. 1 liters volume occupied by materials, hence the effective volume is reduced. The pressure in the cylinder will become 61.4 atmospheric pressures, hence the cylinder is pressurized at 61.4 atmospheres at 20 degrees centigrade. But during this reaction, the temperature in the cylinder becomes very high, even near to the boiling point. So as the pressure increases with temperature, when temperature reaches to 90 degrees centigrade, the pressure in the cylinder will be high, which will be given by P2 by T2 equals to Px by Tx. 61.4 atmospheric pressure divided by 293.15 Kelvin equals to Px divided by 363.15 Kelvin. The pressure in the cylinder at 90 degrees centigrade will be 76.06 atmospheric pressure. Chemicals required for 100 balloons of 10-inch diameters. Since the pressure in cylinder calculated came out to be in the safe range, so we can now safely add chemicals to make hydrogen gas. The chemicals required to fill 100 balloons of 10-inch diameter in the cylinder whose pressure at maximum is 76.06 atmospheres is volume filled equals to 100 balloons into each balloon of 8.6 liters, which means 860 liters of volume. The hydrogen gas needed will be 860 liters divided by 11.11 liters equal to 77.4 grams, and the sodium hydroxide needed will be 1032 grams. The aluminium needed will be 697 grams. The water needed will be 1393 milliliters or 1.393 liters. Following the same calculations for the chemicals required for different number of balloons for any sizes, but the cylinder must remain in the safe range. Excessive chemicals must be avoided which may exceed the safe pressure range The safety must come in the first place. Refilling again with the chemicals will be done instead of pressurizing the cylinder to a higher value than the safe limit. If you have any questions from the entire process, ask in the comments or you can directly email me. I will try to help you as much as I can. You can also help from your side by subscribing to our channel. Now it is important to note that all cylinders does not have a bursting pressure greater than 200 atmospheres, and some cylinders like LPG gas cylinders have a bursting pressure of only 100 atmospheres, and other modified cylinders by welding may have much lesser capacity. Caustic soda is a dangerous chemical and this reaction produces flammable hydrogen gas, so filling balloons with hydrogen gas is not recommended. The balloons may also have some particles of the caustic substance. In conclusion, we hope that this video has helped educate you on the science behind hydrogen balloons and the chemicals required to make them.